All right, the next section I want to talk about is factoring. Now, I know this is everyone's favorite topic. This will be the third year now that you've seen it. I can't stress it enough. If you go into the college tech program that you're in right now, the assumption is you're going into a college program that requires some math skills, and factoring is one of those skills that is a necessity by college standards. So, again, you're not going to learn anything new in this particular unit, and that's why they've emphasized and why it's in this unit is to review it one more time so you can have some level of comfort. So if you were successful at grade 11, it's just a matter of reviewing, getting back into the swing of things. If you weren't successful, this is kind of your final chance at mastering the concept. So the order of factoring, when you find or come across a question and it says to factor it, that means that you need to end up with an answer with brackets. And I always have a mental order that I go through here. And the first type of factoring that I'm always looking for or checking, can I do common factoring? Can I do common factoring? The second one is the difference of squares. Difference of squares. I'm going to talk about each of these if you don't remember the official names, okay, as we go along. Third one is a perfect square. Perfect squares. Fourth, I hope it's a simple trinomial. And now 5, complex trinomial, and that's the one we hope we don't have to deal with. However, trinomial. We're going to review all of these. So that's kind of the order. Now, in your student workbook, if you look at page 36, in the student workbook, there is a flow chart there that kind of helps you out in terms of going through the mental process. Oh, I'm sorry, page 35. And it's a simple flow chart, much simpler than the one we had last year in grade 11, for those that had me in grade 11. But it's a flow chart nonetheless that kind of helps you out in working your way through the type of factoring you're going to deal with. So I would recommend you are afforded a cheat sheet in each unit, and if factoring, being able to pick out the correct factoring is a problem, then that's the one you want to be looking at and making sure it's on that sheet. So start with common factoring. I'm just going to do a couple of examples here and there. Excuse me. So the types of common factoring go down to what we call sort of your easier ones. So the 7x minus 14. So what is common? There's not an x in each term, but there is numbers. So I'm looking at the 7 and 14. Is there a common multiple? The answer is yes, and the greatest common factor is a 7. Divide each term by 7. We'd end up with x, and then negative 14 divided by 7 is negative 2. All right. So there's a couple homework questions that go way back to that level. And then you move into the more challenging ones. So for example, let's go with 2mt squared minus 4m squared t cubed plus 8m t to the 5th. Okay, so this is definitely heading up the difficulty scale. So you look at your numbers first. So I have a 2, a 4, and an 8. What's the largest number? I can divide each of those by, and 2 is the answer. Next, I look at the m's, and the rule is it's the smallest, the one with the smallest exponent. So the exponent on this m is a 1. Here we have a 2 and a 1. So the smallest exponent would be m to the 1. All right, and I'm going to put this off to the side. The variable with the smallest exponent is the common factor. All right. So I'm just going to shrink that down, put it over here somewhere. Okay, so keep that in mind. Going through then the t's, then if we look at the t's, pull out black, we've got t squared, t cubed, t to the 5th. So t squared is our smallest. So now we're going to divide everything by that. So we divide all the numbers by 2, and we take out 1m, and we take out 2 t's. So we end up with the 2 divided by 2 is a 1. Take out an m, take out a t squared. So we took out that whole first term, so we're left with a 1. 4 divided by 2 is 2. I take 1 away from the m squared, leaves me with an m. I take 2 away from the t cubed, I'm left with a t. 8 divided by 2 is a 4. I took out the m, and I'm going to take 2 t's away from there, so I'm left with 4t cubed. All right. So there'll be a couple questions like that, and maybe I'll do one more of that difficulty, and then I'll show you one of the harder ones. So let's do, let's go with 12x cubed y squared minus 16x squared y to the 5th plus 8x to the 5th y to the 7th. So again, what you're doing is you're looking at the numbers first. So I see a 12, a negative 16, and an 8. What's the biggest number that divides all those evenly? Hopefully most of you are saying a 4. Next you look at your x's. I have a cube, a square, and to the 5th. So the square is the one with the smallest exponent. Finally, squared, 5th, 7th. So y squared is the smallest. So now we're going to divide each term by that. So 12 divided by 4 is 3. I had x cubed, taken 2 out, leaves me with an x. I had y squared, I took 2 out, so there's no other y's left. 16 divided by 4 is 4. Taking out the x squared, so it's gone. I'm taking 2 away from the y, leaves me with 3 left over. 8 divided by 4 is a 2. X to the 5th, I'm going to take 2 out, leaving me with x cubed. Y to the 7th, take 2 out, gives me y to the 5th. So there we go, fully factored for this question. Last one I want to show you, this is the more difficult one. This will be kind of the newer one for most people here. If I give you, for example, 3x and then 2x plus 1 minus 5x, 2x plus 1. So you're thinking to yourself, well, there's already brackets here, so shouldn't this already be factored? And the answer is, yeah, it's partially factored. There are brackets. My question is there anything common to both terms? So there's 2 terms here. A term is separated by an adding or subtracting sign. So when I separate it like that with the green lines, is there a common term? And what you find is that each term contains a 2x plus 1. So a common factor doesn't have to be simply a number or a variable. It could be an expression. So if that's true, I can take that 2x plus 1 out. So I can factor it out of each term because they both have them. What would that leave me with? Well, if I take the 2x plus 1 out, you probably don't want to do this with your note, but if it take that 2x plus 1 out, I'm left with a 3x minus, that was the dividing between the 2 terms, or the separation. I took that 2x plus 1 out. I'm left with a 5x. And inside that bracket, they're common terms. So this would reduce down to 2x plus 1. 3x take away 5x is negative 2x. So there we go. Fully simplified. I'll give you one more example with that. So if we have 7 multiplied by 3x plus 1 minus 5x, 3x plus 1. Now that you've seen it once, you start saying, hey, there are 2 terms here because they're separated by that subtraction sign. I see a 3x plus 1, 3x plus 1. That must be a common factor. So I'm going to take it out. And again, whether you want to do this with your note or not, I took it out. I took it out. So what's left? Well, I have a 7. And I have a minus 5x. This time they're not like terms, so I can't combine them. All right, so there we go. So there's a couple of examples like that that you're responsible for. All right. Moving on. Factoring special quadratics. I'm going to get one covered, and then I'll start into the next video. So let's do difference of squares, because they're the easiest, or the easier. So what do we know about difference of squares? So again, this is review. You've got this already. I'm going to put it again in your note for the grade 12 notes. Okay. First thing we know, there's only 2 terms. Both terms are perfect squares. which means you can take the square root of a number, and the exponent on a variable has to be even. And the third thing is it's subtraction. The two terms are being subtracted. All right, so some examples with that. So, first one, let's go with x squared minus 4. We'll start off easy. So again, exponents have to be even. All right, so perfect squares. Maybe add this down below. Okay, you take the square root of the number, and exponent on variable is even. So this is for the people that did not remember what a perfect square means. All right. So with this one, quick checklist. Exponent on the variable is even. Square root of 4 is 2. So that means that I'm going to end up with a pair of brackets, and I'm going to end up with the square of the first term. So this time, in this case, it's the variable. So what times what gives you x squared? It's going to be x times x. What times what gives you a 4? Or just take the square root of 4. So we have a 2 and a 2. And it's always opposite signs, plus or minus. That's how that middle term disappears. Making it a little bit more complicated, I can put a number with the first term. So 25x squared minus 16. So again, can you take the square root of 25? Yes. Even exponent? Yes. Square root of 16? Yes. Subtraction? Yes. Okay, so I'm just going down this checklist off to the side. And this checklist you're more than welcome to put on that cheat sheet. 2 sets of brackets. Square root of 25 is 5. Square root of x squared, or what times what gives you x squared? It'd be x and x. Square root of 16 is a 4. And the signs are always opposite. All right, 2 more examples. So the third one, let's go with, and this one always throws people out, 100 minus 9a to the 4th. So there's 2 things that throw people out, but let's go through the checklist first. Yes, there's 2 terms. I can take the square root of 100. I can take the square root of 9. I have an even exponent, and I have subtraction. So it is a difference of squares. People get freaked out, though, when the number comes first. There's not a variable. People think the variable has to be in that first one. Definitely not. So difference of squares, we got 2 sets of brackets. Square root of 100 is 10, so just using the calculator. Square root of 9 is a 3. Now what times what gives you a to the 4th? It has to be the same term, so it has to be a squared times a squared. So it's half that exponent, and then plus or minus. So there you go. So there's your upper end difference of squares. 4th and final one I'm going to throw in there just because I do this on a test. So I would put, for example, 64 plus 49 x squared. And this is just a check. Okay. Yes, take the square root of 64. I can take the square root of 49. I have an even exponent, but it's adding. So therefore, does not factor. Okay, so you do need to do that mental check. So that gets you through difference of squares. So I still have to go through and talk about perfect squares, and I'll start the next video off with that.